class, I wanted to make a video going through the basics of DOE. So let's take a look at the worksheet. So experiments are performed in all engineering and scientific disciplines and are important parts of the way we learn about how systems and processes work. So as we talked about when we looked at the lecture slides, we are often very tempted to do one variable at a time. We change one variable, study the effect on the parameter of interest, then we change another variable and study its effect. But the problem, and it's a big problem, the problem with changing one variable at a time is we don't see the interactions between those variables. And that can be a very important part. And if we overlook it, our results can be wrong, misleading. So it's important to make sure that we are paying attention to interactions. So instead of this one variable at a time, instead we use design of experiments. Or we call it DOE, design of experiments or DOE. And in these designs, experimental trials or runs are performed at all combinations of the factor levels. Now, we also talked in class about, well, how do we create these, the tests? How do we know what tests we should run? And we're going to look at all possible combinations. And we did actually do that in probability. But what we're going to use now is Yates. And so Yates gives us a way to systematically develop the all possible combinations. And so Yates, if you remember, is we're going to look at, well, first of all, again, this is building the recipe for each experimental run that we're going to make. So in order for us to progress and do all kinds of things that DOE can do for us, we like to build them in what we call standard order. And we're going to use Yates Design Generator to do that. So this is, what this is how am I going to lay out the experimental runs? And for example, this is the first run. This is the second run. This is the third run, all the way down to the last run that we're going to make. And this is called standard order. This is called standard order. So we're going to create our design in standard order. When you go to run the runs, though, run these experimental trials, you're going to run them in random order. Okay, so let's go ahead and design or set up this matrix just as an example. So assume that we have an experiment that we want to consider three variables, A, B, and C. And maybe it is temperature, pressure, and time. So we want to look at three variables and its impact on, say, yield. So our response variable would be, say, yield. So setting up the matrix is like step one. So Yates says, all right, start off with 2 to the n minus 1 low, and then 2 to the n minus 1 high. And what that little n means is the variable that we're talking about in terms of the, let me see if I can find it. Where did it go? Here we go. And there it is. All right, sorry about that. So that little n is, I'm on the first variable, I'm assigning for my first variable. I'm assigning for my second variable. I'm assigning for my third variable. So n equals, in this case, it's the which variable I'm making assignments to. So A is the first variable. So in this case, n is equal to 1. So that means I'm going to do 2 to the n minus 1. So 1 minus 1 low. And then I'm going to do 2 to the n minus 1 high. So 2 to the 1 minus 1 is 2 to the 0. And so that's 1. So we're going to do 1 low, 1 high. So low, high, low, high, low, high, low, high, low. Low, high, low, high. Oh, I've got too many. There are 9 runs in here. That's why that's off. Because notice that we're going to have exactly the same number of pluses as we do minuses. So I've got an extra row on this worksheet. And so this stops at 8. And we know that it's 8 because we're going to do 3 variables, and we're going to do them at a low and a high level. And you may recall that it's levels and then raised to the number of factors. So a low and a high. So that means we've got 2 levels, 1 low, 1 high, and we were considering 3 factors, A, B, and C. So that means there's 8 different combinations of those factors. So we've got 8 rows. All right, so now let's do assign for B. Now B is the second variable, so n is equal to 2. That we're assigning, it's the second that we're assigning to. So we've got 2 to the 2 minus 1 low, 2 to the 2 minus 1 high. So that's going to be 2. So 2 low, 2 high, 2 low, 2 high. So 2 low, 2 high, 2 low, 2 high. All right, now for C, that's n is equal to 3. So we've got 2 to the 2 minus 1. I'm sorry, we don't have that. We have 2 to the 3 minus 1 low and 2 to the 3 minus 1 high. So that's 2 to the 2 low, 2 to the 2 high. So 4 low, 4 high. Okay, so we could do this for however many factors we wanted to include. You know, I could have 16 factors, and so I would just create each one like that. What we've done here is create what's called standard order. Standard order. Now we also have, and we talked about this a little bit in class, this special naming convention, and you're going to see on Tuesday how that comes into play. So the naming of this is we look for each experiment. And so the first one, it says run everything at its low level, set temperature low, set pressure low, set timing low, and then what is Y? Then we would record Y. The second experiment, set A high, B low, C low, and then run that experiment and record whatever Y is. So we have this special naming convention. And so I'm going to start with experiment 2. If the variable, if the factor is at its high level included in the name. So if I look at experiment 2, only A is high, so I name that A. Now I look at the experiment 3, only B is high, so I'm going to name that B. And then the third one, I'm sorry, this is run number 4, 5, 6, and 7. So for run number 4, A and B are high. So I'm going to name that AB. The fifth one, only C is high. The second one, A and C, so its name is AC. The seventh one, B and C are high. So I'm going to call that B, C. And then the last one, they're all high. So A, B, and C. And then for the first one that I just jumped over, it's called 1, and we put it in parentheses. A lot of reasons why all of that, but in the interest of time, we can't really get into that. Now, we started to see it last time, but how we can say, now, what if I want to be able to calculate the effects for some interactions? So I just randomly said, well, what if we wanted to know, as an example, the interaction for BC, and then the third order interaction, 3-way interaction of ABC. How can we calculate that? So it is literally as easy as us looking at the matrix and taking and multiplying. So for column BC, we would take B and C and multiply them together. So a negative times a negative is a positive. So that's positive. Now for row number 2, we're going to say negative times a negative. So that's a positive. Run 3, positive, negative. So that's a negative. Positive, negative, 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 positive, negative, negative, positive, that's negative, and then positive, 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 positive. So, and again, you can see that we've got the same number of pluses as we do minuses. Now for column A, B, C, we have to multiply all three columns, A times B times C. So I've got negative, negative, negative. So that's going to be negative, positive, and two negatives. That's a positive, negative, positive, negative, positive, 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 negative, 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 negative times the positive is going to be positive, positive, negative, positive is a negative, negative, positive, positive is a negative, and the last one, all positives, is positives. And again, look, I've got 4 pluses and 4 minuses. So that's, you know, a good check that you didn't make some silly mistake. That's standard order, standard order. Now you as statisticians and engineers can communicate. Here's the design and standard order. I can talk to my software. This is standard order. Remember though, we always want to run our experiments in random order. Okay, so let's move on. Then we did our experiment in class. So I'm going to catch us up or redo it. And then I want to take us to I want to add like 10 more minutes that we didn't have time in lecture to cover, but I want you to know it. So remember we were saying, oh, we had this process and it was very dependent on eye-hand coordination. And we looked at that the goal was to make as many ticks in some area, in some space. And we said, okay, well, what factors might affect that would be, well, am I using is the space large or is it small? So size of circle, low level small, high level large. And then we said, well, another factor would be, well, hey, am I using my dominant or non-dominant hand? So a second factor, hand used, non-dominant and dominant. So using our DOE naming conventions, which is number of levels raised to the number of factors. Well, the number of levels, we've got a low level and a high level. So number of levels is 2. And the number of factors, we've got A and B. So 2 factors. So this is a 2 to the 2. And that's how you say it. I've got a 2 to the 2. I've got a 2 to the 5. I've got a 3 to the 2. So to run a full factorial, meaning we will run every possible combination, the number of experimental runs is going to be 2 to the 2 or 4. Now, now in industry, that's not always the case, but we want to make more than one replicate of the factorial design. So sometimes we can only make one, but ideally we can make more than one, so we get a measure of the variability. So the number of times that we repeat it, the number of times that we repeat our experiment is n, number of replicates. Whoops, I'm not getting my pen to work, n. So to run a full factorial, meaning we'll run every possible combination, the number of experimental runs is going to be 2. In this case, I'm sorry, in this case, 4. And so now I'm starting over with, well, okay, let's start with this. We want to look at 2 levels of 2 factors. So now let's create our design matrix. So using Yates, 2 to the n minus 1. Oh, it's right here. It's right here. I think we can look up here. Right here, 2 to the n minus 1 low, 2 to the n minus 1 high. So for n, where n is equal to 1, and here n is equal to the second variable I'm putting in. So 2 to the n minus 1 low, that's 0. So I've got, I'm sorry, that's 1. So I've got 1 low, 1 high, 1 low, 1 high. And then b for n equals 2. So that's 2 to the 2 minus 1. So that's 2. So 2 low and 2 high. So there's our design matrix. And then let's assign the treatment combinations, the other naming conventions, where if they were all negative, we use that 1 in parentheses. Negative, I'm sorry, I'm thinking something else. Okay, so A is the only one in the high, that's at its high level for this run. So we call that A. The next run, B is the only one that's high. So we call that B. And in the last run, both are high. So we name that AB. So you put the letter there if that factor is at its high level. So this is the standard order for this particular, for a 2 to the 2. Standard order for the 2 to the 2. Right now, knowing that we're going to want to make some, get a measure of the interaction between those two effects, let's go ahead and put in what that would be for our mathematical equations. We'll never set it. There's nothing to set, right? It's just we need this column to calculate the effects. So we're going to multiply the two columns. So minus times a minus is a plus. Plus times minus, 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 plus, minus, plus, plus, plus. So there we go. All right, so the next thing then is we need to run this experiment in random order and record the results. And then we're going to make a second replicate. So we'll run them in random order and collect those results. Okay, so as you can see, I've entered the data that we collected in class. These were Leah's results. So let's go ahead and analyze it then. So we talked, all right, just thinking logically about this. If I want to know the effect of going from a low level to a high level, then it just makes sense logically. Well, why don't I look at, all right, what did we get when it was low? What did we get when it was high? And look at the difference. So let's actually calculate that. So, and we can even say the average. Why don't I look at the average high minus the average low? Since we took more than one result, we had 2 replicates, didn't we? So let's take the average. So looking at the results then for A, and let me go back to showing you. So here, of these, here's our total. Let's look at the total when A was high. So A is high here and A is high here. So I'm going to say, all right, 103, 118, and then A was low. Let me get a different color for low. So here's A low, and here's A low, and here's low and low. So I'm going to take the average when it was high minus the average when it was low. So I'm going to go ahead then and undo those so I can show you then for the other ones. But those are the numbers that we're gonna choose. So then for the high, it was 103. It was 118. Those were the 2 high ones. So now let's subtract off the 2 low ones. Minus 66 and minus 76. So that was the total. So, and then there were 4 points for each high and low. We had 4 at high and we had 4 at low. So to take the average, we'll divide by 4. So that gives us 79 over 4, and that is 19.75. Okay, so now let's do it for B. So for B, let's go back up here, and B, here's B high. So those are B highs. So it's the bottom 2, and then we'll subtract off these are the high ones. These are the low ones, I'm sorry. The green ones are the low ones. So this time I'm going to take 76 plus 118 minus, 76 plus 118 minus 103 minus 166. So let's take that and work that equation. But again, I'm going to delete those colors so I can show you for the next one. So writing that down, that gives us 76 plus 118. Those were the 2 values high. And then minus the 2 that were low, 66 minus 103. Those were the 2 low ones. All right. And when we work that out, that is equal to, and that's equal to 25 divided by 4 or 6.25 or 6.25. Now let's do AB. So AB, we want to take the two highs. So here's AB high. So I'm going to take 66 plus 118. And then I'm going to say, all right, subtract off the two lows. And those were the two lows. Just in case I want that for something else, I'm going to go ahead and undo that. So let's go down here then and add that up. So AB high, 66 plus 118. And then the two lows were minus 103 minus 76. And that's equal to 5. And then divide by 4. So 1.25. So these are the average effects, from going from a high level to a low level. Just looking at the values, we can see that at least for Leah, A was the big factor for her. A was the biggest factor. So we don't know though, is it significant and all of that? And that's where we're gonna continue with that. So we can actually take what we did logically, average high minus average low, and you can see that is actually the formal formulas for calculating the effect. So the effective factor A is the average high. You can see the average where A is high minus the average where A is low. Factor B for factor B. Average of B high minus average of B low. And same thing for AB. Well, I'm sorry, we've got to add this. That's what this is that's AB high average minus AB low. And if we've got, for a 2 to the 2 design, these are the formal equations. You're going to see we're going to open it up for something. What if we had 3 factors or 4 factors? So these are for a 2 to the 2. It's going to be the same. There's a part of this that I really want to point out, and that is this. I'll use purple to make it different, although that's really dark, isn't it? That piece in here, these pieces in here, in these brackets, in those brackets, those are called contrasts. And all it is the sum of the highs minus the sums of the low. In fact, when I took the average, that's why I was very careful to write out the top. That's the high, high, low, low. So since this is A, remember we have that special notation. So if I wanted the highs, to add up the highs for A, so for factor A, the highs would be, well, A is high here because remember you put the letter there when it's at the high value. So A is high there and A is high there, so plus AB. And where is A low? Well, A is not in the name, so it's low. It's not in there and it's not in there. That's the contrast for factor A. And if you look at our formula, there it is. See, A plus AB minus B minus the 1. So the high minus the low. Now, why am I making such a big deal? Because this piece in the brackets, as long as we're going to use that. We're going to use that in our analysis of variance table. So how I'm going to have you work these problems, I just wanted you to see that this contrast is nothing more than adding up the high, subtracting off the low. So the contrasts, that's what that is going to be. And I can use that. I can use the formula, and you can have the formula with you on the exam. But I can also say, well, I know it's going to be A, because there it's high, AB, and then it's not high there, and it's not high there. Same thing for B. Here's B high, there's B high, and then where is it not high? It's not high in those runs. All right, so we can do that, and we can calculate then what we're going to call the contrast. And you'll see on Tuesday how that contrast comes into play. but let's go ahead then let's just go ahead and do that. I think that'll be good. So for the interaction, then we're actually going to look at that one is going to be AB plus the 1 in brackets minus A minus B. And a reason why, but you know, too much time to go through that in, you know, right now and so on. But let's go ahead and recalculate those values then. And we just did it above here when we calculated. All I'm going to do is we're going to pull out just the top part, and we're going to name that amount the bracket. I'm sorry, we're going to name that amount in the bracket the contrast. So let's go ahead and just for completeness rewrite those down. So A plus AB, so that's going to be 103 plus 118. So I hope you're seeing the value in this, giving them those special names. And then we had minus 66 and minus 76. That's the contrast. And that was equal to 79. And then for B, it was 76 plus 118 minus 66, excuse me, minus 103. And that totaled 25. And then in the brackets for AB, that is going to be 66 plus 118 minus the A, which is 103, minus the B, which is 76, and that totals 5. So now we have what we're calling the contrast. Contrast. And all it is the sum of the high minus the sum of the low. So now officially in our process, first thing we'll do is calculate the contrast. Then the next thing we're going to do is calculate the effect, which keep in mind, we just did that, but this was an example of logically, you know, if we were thinking logically, what would that be? So I wanted to start with that, but then I want to direct you to the official process in solving for it. And the first thing we'll do is calculate the contrast, which is just the numerator of what we just did when we calculated the effects. So now we're going to take the numerator, and in our official formula for the effect, we need the average. So I said that this one right here, when it's over 2 times n, that's only for a 2 to the 2 design. But what if we have 3 factors? What if we have 4 factors? So this is the official formula for the effect. So the contrast, which is just the sum of the high minus the low. It's just the numerator. The denominator, though, that works for any number of factors. So not just 2. So above number of factors, we had k equals 2. Remember, we had 2 levels, 2 factors. So that was a 2 to the k. But for what if we want more than 2? So now what we put in the denominator is n, 2 to the k minus 1. And n is the number of replicates. So this n is the number. Oh, you can see it right here. Number of replicates. And we made 2, didn't we? We made 2. And in our example, we only had 2 factors. So this is equal to 2. We had 2 factors. So I'm going to pull this down to here then. So we've got n, 2 to the k minus 1. So this is going to be 2. We made 2 reps, 2, and we had 2 factors, 2 minus 1. So that's going to be 2 times 2, so 4. So you can see that is, you know, that's the same thing as had we done a 2 to the 2, that's where this came from. That's why it's just 2 to the n. All right, so we know we're going to take our contrast and we're going to divide by n. We're going to take our contrast and we're going to divide by n 2 to the k minus 1. And we just worked out that in our example, that is equal to 4. So I'm going to go ahead and write the first one out officially. So for the effect, it's going to be the contrast, which is going to be A plus AB minus B minus the 1. And then we're going to divide by n, 2 to the k minus 1. So, and again, I'll only do this for the first one. That's 103 plus 118 minus 60. Well, I'll do it in order. 76 minus 66. So there's our contrast. And then we had two reps. It's a 2 level. And we had 2 factors minus 1. So that's divided by 4. So that was equal to, I forget what the number was again. 79. 79. So 79 divided by 4. And that's where we got that 19.75 for the effect. Same thing we got when we just initially started it. So that's how you can do it for any example that I give you, any example that you encounter. So we figured the contrast up here. So for B, the contrast was 25. So the effect is going to be 25 divided by 4. And that is 6.25. For AB, the contrast was 5. And we're dividing by 4. So 1.25. So we have our effects again, but this time we calculated it using the formal calculations. All right, now